We're going to graph a higher order polynomial function in factored form. So here's our example. We have a function f of x equals the quantity x minus 7, x minus 3, and then x plus 2. First thing we'll do is we'll go ahead and find the zeros of the functions, which are the x-intercepts. So the way we do that is we set the function equal to 0 and we solve by the zero product property. So 0 equals x minus 7, x minus 3, and then x plus 2. So we set those each equal to 0. So x minus 7 equals 0. We're going to solve this one for x by undoing, so we're going to add 7 to both sides. So our first x-intercept is at 7, 0. All right, next one, the next x-intercept will be found by setting x minus 3 equal to 0. Solve by undoing, so we'll add 3 to both sides. So this one is at 3, 0. The last one, x plus 2 equals 0. Solve by undoing, so we'll subtract 2 from both sides. So that ordered pair is at negative 2, 0. So we have 3 x-intercepts. Notice that if we were to FOIL this entire function out, we would get something that had x cubed in it. So that tells us that the shape of this graph is going to be a snake. All right. To find the y-intercept, we're going to replace x with 0 and solve for y. So here is our equation. Y equals x minus 7, x minus 3, x plus 2. And we'll set each of those x's in for 0. All right, so we'll simplify each of those parentheses. So those zeros are going to essentially cancel out. So negative 7, negative 3, positive 2. Now we multiply those 3 numbers together. So negative 7 times negative 3 is 21, times 2 is 42. So as an ordered pair, we're over 0, up 42. All right, identify the end behavior. So we talked earlier that this is a cubic function. It's a snake. The leading coefficient is positive. So that's going to tell us it's going to look something like this. It's going to rise on the right, and it's going to fall on the left. And then something's going to happen in between here. It's going to kind of go like this and then come back down. So that is your end behavior for your snake. All right. So what I'm going to do is I'm going to go ahead and graph some of these ordered pairs first and then find the additional points of the relative maximum and minimum. So the 3 x-intercepts we'll graph first, 7, 3, and negative 2. So here is 7, 3, and negative 2. The y-intercept was over 0, up 42. So we need to change this y-axis, increase it. So we'll maybe say this is 10, 20, 30, 40, 50. So we'll go by tens. So over 0, up 42 is about there. All right. So end behavior, let's put in next. So the leading coefficient was positive, shape of a snake, so it's going to rise on the right, and it's going to fall on the left. All right? Now, think about your x-intercept at negative 2, 0. We know it has to rise back up, so that's going to go here, and then it's going to come down, and now some point in here, it's going to come back down and look like that. So we really only need to find one minimum point right in here. So I'm going to erase that for now. So somewhere down in here it is. So I'm just going to go with a halfway point. So halfway between 3 and 7 is maybe, let's say, 5. Okay, so I'm going to choose the number 5 and evaluate the function. So my y equals, I have function x minus 7, x minus 3, x plus 2. And we want to find out what is the value when I substitute x of 5 into the function. What would the ordered pair be? So we say y equals, we substitute 5 into the function, so 5 minus 7, 5 minus 3, 5 plus 2. So we'll simplify that. So 5 minus 7 is negative 2, 5 minus 3 is 2, and then 5 plus 7 is, or 5 plus 2 is 7. All right, now we multiply those numbers together. So negative 2 times positive 2 is negative 4, times 7 is negative 28. So the relative minimum is over 5 down negative 28. So I'm going to erase this here. We did change the units, so this would be negative 10, negative 20, negative 30. So the ordered pair over 5 down negative 28, which is about there. So over 5 down negative 28. Now we can go ahead and graph this function. So it's rising, it's falling, falling, and it's going to turn and head back up. So there is the shape of this graph as an approximation. It could go a little bit farther than that, but we're not really sure, but that's fine. That's a great sketch of our cubic function.